In this video, we're going to talk about what a confidence interval for an unknown population proportion is. So remember that a proportion is a percentage. Specifically, we are talking about a binary situation, binomial. So we are looking at a proportion of successes where there are only two outcomes, success or failure. And we are actually estimating a discrete binomial distribution with a continuous standard normal distribution. We are estimating population proportion P, and the sample proportion that goes with that is called P hat. And by the way, P hat is the number of successes divided by the sample size. Also known as X over N. Sometimes you'll be given X and N and not P hat. Sometimes you'll be given P hat and N. Depends on the wording of the question. Our critical value, when we are estimating binomial situations, we're always estimating with a standard normal curve. So this is going to be a Z critical value, Z star. And for proportions, the standard error for P is going to be the square root of P hat times 1 minus P hat over N. Or P hat times Q hat, which is the probability of failure, over N. So our formula for calculating is going to be P hat plus or minus Z star times the square root of P hat 1 minus P hat over N, all under a square root. This is called a 1 prop Z test on, or int, sorry, because we're doing intervals, on your calculator. So if you are looking for this on the TI-84, you're going to go stat, tests, and you're looking for 1 prop Z int. So it's option A on your calculator. If you pull that up, you'll notice it's actually asking for the number of successes in the sample size. That's the most common way that these problems are phrased. If you were given P hat and N, how do you find X? So X is going to be equal to P hat times N. Probability of success times sample size should be number of successes we expect to see. And you need to round that to a whole number. If you plug a decimal value for X, your calculator is going to throw a tantrum because you can't have a portion of a success. A trial was either a success or a failure, so we're counting by whole numbers. Let's go ahead and do 2 examples really quick. So first example says, suppose 250 randomly selected people are surveyed to determine if they own a tablet. Of the 250 surveyed, 98 reported owning a tablet. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of people who own tablets. So the problem was really nice. They actually defined our population parameter for us. So the parameter of interest is the proportion of people who own tablets. That's our P. We're given a sample size of 250 people. We are given a number of successes. The number of people who own tablets is 98. We are told that our confidence level is 95%. Because this is a Z interval for a proportion, a 1 prop z-int. I know that I'm using inverse norm to find this guy. So I'm going to inverse norm, and it's going to ask me for the area, which is going to be 0.95. It's going to ask me for the mean, the standard deviation, and then the tail. And I want it in the center. So it's going to give me my z star. And we're going to go ahead and run that together. So second bars, inverse norm, 0.95, area in center, and we get 1.96. Now that we have all those moving pieces, we can build our interval. So p hat plus or minus z star times square root of p hat 1 minus p hat over n. And we need to figure out what p hat is, and I know p hat is going to be x over n. X over n. So p hat equals 98 divided by 250. So 0.392. So the center of my interval p hat is 0.392 plus or minus, and then our critical value of 1.96, and then our standard error, big ugly square root. We know our p hat, 0.392, and then 1 minus p hat is 608. 0.608 divided by our sample size, which is 250. So same idea, I'm going to enter that on my calculator with the minus first, and then do the plus second. So I get 0.331 to 0.453 rounded up. And you'll notice that this value here sits right in between those two values. So that's a good sign. My last step, I would write a conclusion. So we are 95% confident that the interval from 0.331 to 0.453 captures the true proportion of people who own tablets. I don't know why that came out like a 1. All right, let's go ahead and try one more. So it says a survey of 100 Americans found that 68% said they find it hard to buy holiday gifts that convey their true feelings. Find the 90% confidence interval of the population proportion. So 95% confidence interval for a population proportion. I know I need to define my proportion. So population proportion of Americans that find it hard to buy holiday gifts. I'm going to shorten this to find gift giving hard. Excuse me. They only gave us a couple of numbers. So they said a survey of 100 Americans. I know my sample size is 100. And I know that the proportion of that 100, so a sample proportion, the 68, said they find it hard to do the gift giving. So p hat is 68% or 0.68. My confidence level they said a 90% confidence interval, so 0.90 or 90%. So I'm going to do two things. I'm going to use these to calculate x. I know x is going to be p hat times n. So 0.68 times 100 is going to be 68. I expect 68 of those 100 to find gift giving hard. And then I'm going to use inverse norm to find my critical value. So second r's inverse norm, our area is now 0.9. And we get 1.645. We are doing a z interval for a proportion. So p hat plus or minus z star times standard error for a proportion, which is p hat 1 minus p hat all over n. So 0.68 plus or minus 1.645 square root 0.68 times 0.32 all over sample size of 100. So we get 0.603 to 0.757. And we're going to check this on our calculator by running that one prop z int. So option A, one prop z int. We know our number of successes was 68. We went back and figured that out of 100, and our confidence level is 0.90. We're going to go calculate, and you'll notice it gives me exactly what I got manually. So that 0.603 to 0.757. Last step, we would conclude, we would summarize our findings. So we are 90% confident that the interval from 60.3% to 75.7% captures the true proportion of Americans that find it hard to buy holiday gifts that convey their true feelings. All right, if you have any questions on what you've seen in these confidence interval videos, feel free to send me an email or drop by office hours. Otherwise, I will see you in our last video for this week.